Hi everyone. Okay, let's continue to discuss the examples questions for the Newton's law topic. Okay, um, here we have a box with a mass of 10 kilogram is at rest on a frictionless surface. Okay, firstly, before we continue to work on this problem, we have to define whether this case is the first, second, or the third low case. Yeah, we can define it first. Okay, let's say that this is at rest. Yeah, the box is at rest. So because the box is at rest, it's allowed for the first law of Newton exists in here. Okay, and on the questions, we know that the box is acting or working on a frictionless surface. Yeah, so we can neglect here for the rough surface. Yeah, in this case. Okay, first we have to draw a free body diagram of this system. Yeah, because there's no an external force here, so we can just write first of all is W or a weight force, then second one is normal force, and oh yeah, don't forget to give the axis. Okay, for the rightward it's positive x and the upward is positive y. Okay, then for the x itself, there's no force, so we can just focus on the y-axis, yeah, to find the net force. Okay, I guess um, it's already answered, yeah, for the number A, for the point A. Then for the point B, yeah, determine the weight and normal force. Okay, first of all, for the weight force, it's simply we can use the W equals M times G, and M is 10 kilogram. G, if there's no information about G or gravitational acceleration, so we can just insert it as 10 meter per second squared. Yeah, so it's 10 times 10 equals 100 Newton. Okay, so the weight force is 100 Newton. To find the normal force, we can use the sigma F equals 0. This is the first law of Newton. Okay, sigma F, yeah, this is the force, yeah, the sum of all forces acting on the object, yeah. But in here, we can just get two force, that is W and N, yeah, which directed upward and downward. Okay, because N is directed upward, so it's positive. Then for the W, it's negative because it's downward. So sigma F will be equal to N minus W equals 0. So N will be equals to W, which has value 100 Newton. Yeah, so we have the same value for the normal force and weight force in this case. Yeah, maybe in the other case we will have a different value. Okay, I guess this is the sigma Fy, yeah, because we're only considering the the y-axis, yeah, for the force acting on the object. Then to find the net force, actually we have already got the point, yeah, got the answer. The net force is equal to 0 because there's no motion. There's no motion, yeah, which can be represented that there's no acceleration exists in here. Yeah. Okay, I guess it's enough, yeah, for the first questions. Next, for the second questions, actually this is the same picture but with different cases. Yeah, the first one is W. We can redraw for the free body diagram, okay, like this. But we can focus on the next sentence, that the box is pushed by a force 5 Newton. Okay, there's an external force right now that is 5 Newton. Okay, so because in x-axis just acting one force that's directed rightward, so it must be there's an acceleration which directed rightward also. Okay, so this is the free body diagram of the system. Okay, then to answer the B point, determine whether the box is moving or not. Okay, the box will move. Okay, due to the existence of an external force acting on the box. Okay, or the second law is a load. Okay, that's all for the number B. Then for the C questions, what is the net force acting on it? Okay, if we are asked about the net force, so we have to find using the second law, that sigma F, oh sorry, it's not equal to 0, but it's equal to M times A. Okay, first of all, we have to focus only on the x-axis, because on the y-axis it will be equal to 0 because there's no change in position or the motion, yeah, in the y-axis. So it's the first law. For the second, for the x-axis, it's a load for the second law. Okay. Okay, so sigma fx is just f, yeah, because there's just one force, yeah, in the x-axis. M is 10, A is A, then F is 5. So we will have that A is equal to 0.5 meter per second squared. Yeah, because we know that 5 divided by 10 is half, or 0.5 meter per second squared. Okay, this is the acceleration actually. This is D. And to find the net force, so sigma F, yeah, sigma Fx, it's equal to M times A. The M is 10 and A is 0.5. Yeah, so it's 5 Newton. Actually, to find the sigma Fx, it's already given, yeah, in this equation, yeah, because sigma Fx is only equal to F, so sigma Fx also equal to 5, yeah. Okay, like that. Okay, next for the number 3. Here, it's the same box, yeah, is at rest again on a frictionless surface, but it's connected by a rope to the other mass of the box. yeah, which has value 5 kilogram through a pulley. Okay, for your information, this is a pulley, or in Bahasa, we are familiar with the term katrol. Okay, katrol. And this is a rope. Okay, let's say because there is weight force here, W2, so there will be a motion, yeah, that's move, um, that makes this mass move, yeah. Let's say the motion directed downward in this side, and for this side it will be directed rightward. Let's say that this is A1 and this is A2 with the same value, I guess. Okay, and because there is a rope here, so there will be a tension force. This is T2 and this is T1. Okay, as usual, we can also draw the free body diagram. This is normal force and this is weight force. Okay, there's a question maybe. Why there's no normal force in the M2? Okay, as we have already discussed earlier, that normal force, it can also be called um, as contact force, or if there's no contacting force, yeah, with the surface, with any surface, so we can't get a normal force in here. Okay, as we can see, and the M2, there's no contact surface, yeah, contacting surface, so we can just use W2 and T2 here. Okay, and don't forget to give sorry, to give the x and y axis in this free body diagram. Okay, I guess this is already answer the A questions. Okay, next, for the B questions, we are asked about the net force acting on the system. Okay, to find this answer, yeah, for the questions, actually we can firstly um, look at the force that makes this system move, that is W, yeah. So we can focus on the M2 first, yeah. So sigma F2, yeah, because the direction of the motion is only in y-axis, so we can only just use the F2y here. So sigma F2y equals m times a. Okay, then m, for the m itself, we can use the mass 2, yeah, so it's equal to 5. Then a, it's still undefined. Then for the sigma F2y, it will be equal to 2T2 minus W2. Okay, as we already know that W2 is equal to M2 times G. M2 is 5 and G is 10, so it's 50 Newton. Okay, so we will have T2 minus 50 equals 5A. Then T2 will be equal to 50 plus 5A. Okay, let's say that this is the first questions. Then, for the second focus, we can start focus on the M1. Okay, because the motion in this mass, yeah, in this box, is just directed in x-axis, so we can just only on only focus on the x-axis, so it's f1x. Yeah, it's equal to m1 times a. The a will be the same actually because the motion, because I guess it's a system, yeah. And the t2, it's also the same, yeah. t1, t2, let's say it's equal to t. Yeah, we can change this into t maybe after this. Okay, we can continue first, yeah, to the okay. Sigma f1x is equal to t1, yeah, because there's no force more, yeah, acting on the m1, so it's just t1. m1 is 10, then a is still a. Okay, it's the second equation. Now we can make an equation t1 is equal to t2, so yeah, it's 10a will be equal to 50 plus 5a. Okay, so 50 it's still here. Then for the 5a, we can have 5a in the left side, so a will be equal to 10 meter per second squared. Okay, this is the acceleration actually. Okay, so we have already answered for the C questions. But for the B questions, yeah, we can back to one of the net force. Yeah, maybe we can use the simple one, that is wait a minute. Yeah, that is T1. Yeah, that T1 equals 10 10 times A. 10 is 10, A is 10, so it's 100 newtons. Yeah, so this is the B answers. Okay, I hope you can understand. If you still can't get the point, so you can just ask me on the class meeting. Okay. Okay, next. I guess this is the last questions. Okay. A box with a mass of 10 kg is on an inclined surface. Okay, I guess it's actually the same as the previous questions, but the box with a mass of 10 kg is located on inclined surface. Okay, this is inclined surface, or in Bahasa, we are familiar with the term bidang miring. Okay, actually, I haven't insert the angle. Okay, let's say that the angle is equal to 30 degrees. Okay, then um, let's assume that the gravitational acceleration is 10. Then a force, an external force that pulling the mass of the box is F, which has value 5 newtons, is applied to the box. Okay, to write the to draw a free body diagram, we can start by making x and y axis here. Okay, it will be different, right? Yeah, for the horizontal one, yeah, to the inclined surface one. Yeah, the x, it's adapting the angle of the surface. Yeah, so it's adapt with this surface. Okay, okay, and then to draw a free body diagram, it will be a bit different. Okay, first of all, we can draw a weight force like this. Yeah, this is a weight force. it's directed downward, still downward. Then actually, because this is in an inclined surface, so the W can be projected to this side because it's the same, it's opposite direction with the Y, so it's in Y-axis, yeah, so it's WY, okay? And for this one, this is WX, okay? I hope you can get it. Okay, maybe to make it clearer, we can rewrite or redraw this free body diagram in a bigger one, like this. Okay, this is W, and this is, okay, this is WY, and it's WX. Okay, for your information, for this angle, it's equal to also theta, yeah, as the angle of the inclined surface, okay? And to find the value of WY and WX, we can use the projection of vectors using this information, or W, or weight force. Okay, we have to remember again the concept of trigonometric ratio, yeah, which is this side is it can be represented by opposite side, yeah, because it's in front of the angle, and this side is the adjacent side, and this side is hypotenuse, yeah. Okay, and one more, I want to tell you that if we have a vector like this, yeah, it's vector of wx, so it will be equal to this vector, yeah, so it's also wx, okay. Okay, based on information we got from the trigonometric ratio that we know is sine theta, it's equal to opposite divided by hypotenuse. Opposite is depan and hypotenuse is miring. For the opposite itself, it's represented by wx, then hypotenuse is it's w. Yeah, so sine theta will be equal to wx divided by w. So when we want just to know the wx, so it's equal to w sine theta. Okay, so it's w sine theta. Then for the wy, we can use the cosine, since cosine equal to adjacent divided by hypotenuse. Okay, so cosine theta will be equal to wy divided by w. Yeah, as we know that the adjacent can be represented by wy. So wy equals w cos theta. Okay, I guess it's easy, right? I hope it can be easy for you. Okay, I guess we have already answered for the A questions, that is drawing a free body diagram of the system. Oh yeah, one more. I guess we forget to write the normal force. Yeah, there's a normal force acting on this surface, but it's directed positive y-axis. Okay. Okay, where's the cursor? I'm sorry. This one. Okay, everyone. So, next questions. What is the net force acting on it? Okay, because for the motion in this situation, there's no motion in y-axis because it's it's still in the first law, that is the law of inertia for the y-axis. Yeah, so in y-axis, the law that's allowed is sigma f equals 0. And this is the first law, or the law of inertia. Then in x-axis, we can find the, what is that? The motion, yeah, because there is the wx, yeah, or the force from the weight, yeah, but directed in x-axis. Then there's also F, yeah, in here, or as an external force. Okay, we can use the second law of Newton's. Sigma Fx equals ma. For the sigma Fx itself, we can write the F as positive and the Wx as negative. And it's equal to ma. Okay, so I guess we can move to the other side here. I guess it's enough. Yeah, we can just continue here. Okay, for the F, it's already defined, that is 5 Newton. And for the Wx, yeah, here we have W sine theta. So Wx equal to W itself is m times g. M is 10 and g is 10, so it's 100 Newton. Yeah, so Wx is 100 Newton times sine 30 degrees. Yeah, so because sine 30 degrees is equal to half, so half times 100 is 50 Newton. Okay, so Wx is equal to 50 Newton. Okay, then for the m is 10a. Okay, so we will have minus 45 equals 10a. So a will be equal to minus 4.5 meter per second squared. Okay, again, I have to inform you that the minus sign in here, it's only told us about the direction of the acceleration or the motion. Okay, so it's enough for the acceleration. So if we are asked about, is the box moving? Yes, the box moving. What is the acceleration when the box is moving? Okay, the acceleration was 4.5 meter per second squared. But in minus x axis for the direction. Okay, then what is the net force acting on it? Okay, actually for the net force we have already know, yeah, from the sigma fx, that sigma fx is equal to 5 minus 50. Yeah, so it's 45 Newton. Maybe we can make it as absolute number, yeah, so it will be also it will be always be positive, yeah. So sigma fx equals 45 Newton. Okay, I guess it's enough for our learning today. I hope you can understand what I was saying about in this session of the materials. Okay, let's sleep because I'm really sleepy right now. See you everyone. Assalamualaikum warahmatullahi wabarakatuh.